Okay, so here is the Lyrec motor switching system. It's not in an enclosure yet, but this is essentially what's going to be in there, minus a transformer that will isolate the motor from the wall, so in case there's a power surge, it won't blow your coils in the motor. Also, the run cap will be positioned inside of the enclosure. So really you'll just have, a power cord going to the box and a couple of XLR jacks that will supply the voltage to the motor, and also connections for a couple things. So right now I have a speed selection switch, so that's what this guy is, 33 or 45. I can of course make this system to handle more speeds. If you want 78 or if you want the half speeds, I can totally do that. I can add half-wave rectifiers and a couple more relays, and no problem. There's no issue there. This is an indication of whether the motor is on or off, right? And then also, if you look at the Neumann dock, you're not supposed to power the coils to the motor while the start motor is engaged. So whenever you press the start motor button on the lathe enclosure, it actually cuts the power to the main coils in the Lyrec. So this system does the exact same thing. It allows you to take an impulse from that switch. So you will rewire that switch. That switch is multi-poled. It's a multiple throw, and two of them are opposite. So when you press it for the start motor, it decouples, disengages one of the poles, right? So the pole for the start motor is different from the pole from for this, and they're actually inverted, right? So I get signal when there's no start button activity. I don't get signal when there is start button activity, and that is used by the system to determine whether the main coil relays should be on or off, right? So that explains all that. This is simply a tact switch, a momentary tact switch, which turns the system on or off, right? So press it once on, press it once off. You can press it and hold it as long as you friggin' want. It's properly debounced and also properly stored, that bit, right? So, wiring block, a bunch of the stuff is not wired up because A, I don't have the leads to both speeds. B, wired up output wise. I also don't have a run cap wired in here, but that doesn't matter. So I'm going to show you really quick using this. What I'm going to do is turn on and off this lamp. So I've got the output for the 33 going into this guy right here, which is just standard socket, and then that is plugged into the lamp. So I've got this guy, which is 120 volts straight from the wall, going through 33 relay outputs to here. This outputs to the lamp. So when I go and turn this on, the lamp turns on. Right, and so if I do this and I switch speeds, of course, lamp's going to go out. But the other relay is on, you can tell that, and the motor is still on. If I was to switch back speeds, lamp turns on. Now if I simulate hitting the start button right now, lamp turns off. But motor is still saying, I'm on still. You haven't turned me off, you just hit start. So when you go ahead and hit start again, and you might have heard some buzzing because I just touched the lead with my finger, which obviously grounds it, so it made a buzzing sound. That's all that was. So there we go. Start on, start motor off. I go ahead and turn the entire system off. This is just an indication that the board is running, right? It's a heartbeat, if you will. I put tape over the rest of this because, I'd like to keep my circuit to myself. So keep prying eyes out. You can buy one and then you can know what the circuit is. So cool.